first of all, so when we talk about valve, or you can see it here on the very nice poster, this is a valve with a what you call red color hand wheel and also the black color hand wheel. And for your understanding, what is actually valve? From the most basic or from the definition itself of valve, valve is actually a device that regulates, directs, or control the flow of fluid. Fluid, we can have a liquid, gas, air, or sometimes even a solid, or we so-called multi-phase, means a solid with liquid or solid with gas. Is used to start or stop or to regulate by a movable part that opens, shuts, or partially obstruct one or more passageway. So this is the definition of it. So on the basically the idea is we use a valve to actually control, or we so-called start, stop, or regulate by actually controlling the movable part. So on different valve type design, there's a different movable part. We will actually bring it into a more detail on the next class about the common valve type. On today as well, I will share a little bit about the two different type of valve motion. Okay, so a very fun fact or very interesting fact, if you never heard about valve, or you are fresh grade, or if you are university students, or even you are in the industrial but you are not from the mechanical or instrument background, do you know that actually all of us, we are carrying a valve? Yeah, try to imagine in our organ, actually we do have a valve. Is built in a healthy person itself on every one of us. Valve or BM in job. Yeah. Hi Aswadi. Can hear. Okay. So the answer is that yes, this is our heart. So our heart actually is responsible to transfer or to bring the blood to all over our body, to our brain, to our vital organs, to actually to continuous supply of oxygen. So of course, I'm not going into a biological about all this valve. On the upper part is the atrium and the bottom part is the ventricle. But you can see here we have a pulmonic valve, uh, valve, and so on. I'm not a biologist, but just to tell you that valve, mechanically, yes, in a process valve, but in our body itself, we do have a valve as well. Other than this, if you are first time heard about valve, or if you are first encounterment with valve, actually in our daily life, in fact, I guess every morning when we woke up, you will actually how to say interact, or actually you use a valve. Do you know what is it? Yeah, our heart. Yes. Yeah, every morning try to imagine. I think when you wake up and you're preparing to work, you will actually keep in touch. Not to say keep in touch, you actually touch a valve, or actually you use a valve, which is, yeah, it seems very familiar, right? Yeah, so this is a valve, or we call tap water, or we so-called faucet. Every day, I believe, when you want to brush your teeth, wash your face, or you are actually going to shower in the morning, so you actually use a tap water. So this tap water, since young or since kid, we have been using this. But do you know how actually it works, or how magically this mechanical device actually control the water? I mean, we are using to control the water in our household or in our normal plumbing. We are used to control the water. So how does it work? Okay, so this is actually the mechanism built within of it. So during the close, you can see there's a splinter. The splinter will actually, when you fully tighten, so the washer and the seat is sitting close on the we so-called the orifice, or actually the orifice which allow the water to pass through. So when you open it, when you pushing, either your tap water is using, or your faucet is used to turn, or you're using the lever type. So when the seat and the washer is away from the orifice, then there's a passageway allow the medium or the water to pass through. So as simple as this, this is the very basic mechanism of a valve. But how do we use it differently in our process industry? Yeah, I will continue to bring you all into it. Like just now we mentioned the principle, the function of a valve, we use it to start or stop, means like your tap water again, you open it, so there's a water flowing out from tap water, or you stop it, you close it. So based on the valve state, the valve state means you open it or close it. The another function is we use it to regulate the flow and pressure within a piping system. So this is the upcoming topics we will be covering, which is we talk about how can we use the valve, we so-called control valve or modulating control valve to regulate, to control the flow and pressure. Not limiting only to flow and pressure, also to temperature, also to level control. Okay, the next one also we can use it to control the direction of flow within a piping system. So this is actually, or sometimes in application, we will say this is a mixing valve or a diverting valve. So we can actually control the flow direction of the in the piping system. So for example, there is a main supply pipeline. Then we actually, for example, like your home. So there's a main supply from your tanki, from your reservoir. Then you actually they supply to your bathroom, supply to your kitchen, supply to your what do you call to your car porch and so on. Yeah, so this is actually there's a diverting or mixing function of the valve as well. Another type is we can use it to throttling flow rate within a piping system, which is this one is more or less is very similar to the regulating flow or the pressure. Okay, number fifth, this one is improving safety through relieving pressure or vacuum in a piping system. So this type of valve is most of the time they are actually self-actuated, or we so-called self-acting valve. Is a pressure relief valve or pressure safety valve. So the function of this is actually to protect, for example, you have a very big vessel or tank. So it's to prevent if there's a pressure, over pressure, or the pressure build up is higher than the design of the equipment. So you actually relieve it or release it to a safety state. Okay. So on the right hand side, you can see this is actually a sample or it's an animation of a butterfly valve. So, okay, now it's going to on the closing state. So when it's closed, we so-called the stopping the flow. So there's no flow on the left-hand side. When it opens, actually the flow is allowed to pass through the passageway and is flowing through the pipeline. So far, do you all have any problem? Engineering plus biology. Okay. Yeah, so today we'll share about the very fundamental and the basic about what we need to know about WAF when you first hear about WAF or the industrial WAF. Okay. Oh, sorry, I think my camera is blocking the view. I will just temporarily hiding myself. Okay, now looks good. Okay, so on the WAF opening methods, uh, when we talk about WAF, so most of the WAF they actually designed to achieve the similar goal, which is to starting or stopping, or to regulate, or to control, or to diverting or mixing on the similar goal. On the mechanically, they actually design in a different way or different construction. So the different opening methods is actually affecting the overall performance of the WAF design or the WAF construction. So it's either to determine about the flow control, the performance of the flow control, or how quickly the valve can operate. So basically, in this opening method, we can put it into two categories. First category is on the rotary motion, or another is a linear motion, which means it's working on the vertical motion. Let's go into the example of rotary motion. So rotary motion here, I'm showing you an example of a ball valve. So in rotary motion valve or rotary valve, there are a lot of types as well. For example, on the check valve, butterfly valve. So here I put an example of ball valve. So you can see the flow passes through the bore in ball. Okay, so when the ball close, actually the flow stop. So is we so call as well to quarter turn, means is the operation is in a 90-degree or quarter quadrant. Here there's a very simple animation to show to you. So you can see the blue color part is a ball itself, because the trim or this design looks like a ball. Okay, so and the empty part, or there's a passageway, we call it a bore, B-O-R-E. Yeah, you can see flow passes through bore in ball. Okay, so when the bore is actually in a line with the pipeline, or in a line with the upstream or downstream, or the inlet or the outlet, so the flow is able to passes through. If it's actually on a closed state, you can see it here on a closed state, so the bore is actually in the cavity, so the flow is not able to pass through. So this is a very simple example of rotary motion. Jaja Razin, B-O-R-E, yes, correct. Bore. Bore is means on the we so called the empty part, or actually it is the orifice of the ball valve. Okay. So the next one we have it here is a linear motion. So why do we call it a linear motion? In this graphic or in this diagram, you can see, especially the yellow color part is the wedge gate, or we so call the trim part. So on the full open position, you can see the wedge gate is at the top position. When you close it, now the wastegate is get in contact with the valve seat. Over here we don't show the seat, but you can see that, or you can imagine that. So now on the left diagram, the flow is able to pass us through the valve, and on the right diagram, the flow stopped by the valve gate or the valve orifice or the valve trim. Okay, so this is an example of the linear motion because the valve trim is moved. The movement is in vertically from top to bottom, top to bottom. Comparing to this rotary motion, you can see it is actually in a turning or a rotation motion. Yeah, this is so simple. In simple way, we actually have two types. One is a rotary motion, one is a linear motion. On the linear motion, you can see this as well. Is a For this type is actually how can we operate it is through a hand wheel. In the middle, you can see there's actually a hand wheel. So hand wheel we are using the rotation motion, but the trim itself is a linear motion. So we rotate the hand wheel to control on the opening and the closing. And for this one, you can see on the red color part is actually a lever lah. So you can hold it and you can turn it in a 90-degree or we so-called quarter turn position. Okay, so now we after we describe about there's two types of motion. So on the linear type and also the rotary type, this is actually to control the valve or we operate the valve. There's a different of actuations methods. So we can actually categorize it, or we can fall under three categories. On the first type is on the manual valve. In the manual itself is require a human interference or is actually a human involvement. So we can do an adjustment via the hand wheel, hand lever, or the gear wheel. So on the I can okay. If you can see my arrow here, I can't use the laser pointer. In the left hand side here, this is an example of ball valve. So how can we operate this ball valve? You can see it here. This lever, lever lever, which is wrapped in a blue color protector. So this is a quarter turn valve. So how can we use it is we turn it in 90 degrees. On the middle part, this is also a ball valve, but because this ball valve, the size is much larger than the left hand side, or we actually there's a consideration when should we use a gearbox, especially the valve size get larger and the pressure rating as well. So the torque required to operate the valve is higher. So we can no longer using a hand wheel because the torque is too high for us to operate. So we will get assisted by a gearbox. So this is a gear wheel. When we turn the gear wheel, when it's linked to the gearbox, and we can operate or quarter turn our ball valve. And on the right hand side here, this is a sample of butterfly valve. Similarly to the middle part, this is actually both just a different valve type design. This is a ball valve, this is a butterfly valve, but both we are connected to a gearbox and operate through a hand wheel. On the second part, okay, so this is a actuated valve. Just now when we talk about valve, you can see this is a valve, this is a valve, the black color is a gearbox, this is a valve, and the blue color is a gearbox. And now we have an actuator. What do we mean by actuated valve? Yeah, okay. So the actuated valve is often connected to electric motors or pneumatic or hydraulic system, or we so-called a pneumatic actuator or hydraulic actuator. So on this application or this design is actually allowed remote control. It can be automatic, so it doesn't require a human or our operator to be at the site to actually operate the lever or the hand wheel. So why do we say about or how can we actually control it remotely or using automation? By having this design or construction using an electric motor, pneumatic actuator, or hydraulic actuator, we can actually put the application into a very high precision and also a very large scale. Mean we can control a lot of units, a lot of valve at the same time. Comparing to the previous one on the manual valve, which means you need an involvement of one operator for each of the valve. Okay, let me see if you can see my, yeah, you can see my arrow. So on this one, this is actually a ball valve as well. Let me see. Wun Kai Fu. Valve with bigger size and multi-turn normally operate by gear, while small quarter turn is by lever. Yes, you are correct. Yeah, thank you. So on this is a ball valve, and the middle part, this is actually a actuator. So actuator comes in a different design as well. We will go into the detail about the design and construction of each pneumatic actuator in another chapter. So on the top, this is actually a positioner, or we so-called a controller. So how it works, comparing to previously, we have a lever or we have a hand wheel to actually operate the valve. Now, this actuator either is a either is a pneumatic or hydraulic actuator. So this is actually the brain. Where's my arrow? Yeah. This is actually the brain. So we were giving the control signal to this device. This smart device, most of the time is electronic. As well, we do use a pneumatic type as well to control the pneumatic or to control the hydraulic get into the actuator. In the middle part as well, you can see this is like a very big head lah. At the bottom, this is a three piece ball valve body, and in this one in a beige color or in a brown, in a creamy color, yeah, this is actually an electric motor. So as well, the similarly, we are giving the signal, electric signal to this motor in order to operate the valve to open or to close. And on the right hand side is different from the left and to the middle. This is actually a linear valve. You can see the actuator and also the construction is actually much taller. So on the bottom, this is a valve as well, and the blue color is the actuator, and this is the brain or the controller of this component of this assembly. So we are giving the signal to this brain, to this controller, and it will control the either it's a pneumatic or hydraulic into the actuator. And is how it works is actually it will control the stroking of this valve linearly. This is a linear valve up and down by the percentage. So comparing to we are using on the manual type, which in our person, for example, I want to open 2% more, 3% more, or I want to close to 30%. How accurate it can be means there could be some parallax error, means we are looking at the opening of the valve, or if you are very difficult to reach, or at the site there are so many valve, maybe some people will actually get to the wrong valve. I mean if it's a human error. So by using this actuation method, we can actually control it by using more precision way, means we send a signal, electric signal, electronic signal to the controller and to control the function or the position of the valve. So this is the actuated valve. And on the third category, one moment, let me see if there's any comment. If you all have any questions, please leave your questions in the comment box. Then I will attend to you later. Yeah, I just sent some comment just came in. Hazira, ini saya tahu ada kat Singki rumah. Chachen, easy to understand. Okay. Okay, so number third, this is actually a automatic valve, or we so-called self-acting valve, self-actuated valve. So this type of valve is designed using a mechanically, or most of the time is using spring to activate when a specific flow condition is met. For example, on the left hand side, this is a check valve. At the middle, this is a pressure regulator, so it's controlled by a spring as well. And on the right hand side, this is a sample of the pressure safety valve, or we so-called pressure relief valve. It depends on the the construction design, but externally you look at it, pressure safety valve and the pressure relief valve is almost looking the same. Yeah, just on the method. So how does it work? On this left hand side, this check valve is actually this is a dual plate check valve. So it's on a rotary motion. You can see there's actually a spring located in here. So it's only allowed on one way one-way flow. When when there's a backflow coming from the downstream, so the it's actually exerted the force onto the spring together, and it will close the flow passage. And in the middle, this is a pressure regulator. This pressure regulator, how it works is actually in the detailed construction, we will carry in other topic as well. But in this chamber, there's actually a spring located here. And how can we regulate the spring, or how can we adjust the spring? It will performs onto the controlling on the pressure in this cavity. And same to this one, you can see this is a spring, so pushing down the cylinder. So if the pressure is higher than the force of the spring, imagine from the bottom to the top. So now when the force from the spring is higher than the inlet, so the valve will remain closed. If the pressure is higher than the force of the spring, yeah, so it what do you call push over the spring up, then the cavity, or there's a what do you call, the fluid will relieve through this another flange type pin. Normally the actuator will be very heavy. Okay, this is from Wai Chong. I've seen some valve got both gearbox and actuator. Yes. Okay, so first, attending to Wai Chong, the actuator design, it depends on the valve construction as well on the valve materials, or we so called the valve specification. The design, I would say, is according to the sizing calculation. Some of the design, because there's a reason of the actuator also comes in different construction. For example, rack and pinion, or we so-called Scotch yoke, or we so-called piston type, we so-called diaphragm piston type. So different type of construction, it will actually having a different torque output curve. This is depends on the application engineer and also on their study about the torque curve of the valve, because ball valve and butterfly valve, they will have different torque curve. So there are different suitability in between the different type of actuator and different type of the valve. So how can it be used or coupled together? On Jaja Razin is some valve got both gearbox and actuator. Yes. So for example, you have an actuator, but in case there's a failure, for example, there's no signal or there's no pneumatic, means no air lah, or the hydraulic system failure. So you couple together with the gearbox to perform a manual override. Means if it's out of control, you cannot use automation, you cannot use the remote control. So at least you can attend by using the hand wheel. Okay. Oh, 159, very fast. So this is the importance of valve sizing. Selecting a proper valve size is very essential. Of course, when a valve size, try to imagine when you're buying a bigger material, then the cost is higher. You select a accurate or proper valve size so you can optimize your cost saving, and also ensuring safe, accurate, and reliable operations. Because when your equipment, your valve is a larger size, it will be heavy as well. On the safe and accurate and reliable operations, involved into the actuation sizing as well, and also your valve construction or your control valve sizing as well. In a control valve sizing or the flow control condition or flow control sizing, we'll capture into different topics later, because now every Monday we only have 30 minutes. So on the things to consider in the valve selection, first thing we can consider on the valve flow coefficient, or we so-called the CV value. What is this? If I explain to this, I will need another 10 minutes, but just a glance for you, an overview to you. So about the valve flow coefficient, we will capture this topic or this subject in the next upcoming agenda. So the physical dimension and the weight of the valve selected, the flow characteristic, and also the inherent performance of the valve. Because we have different valve design, we can have a gate loop check valve, ball valve, butterfly valve, pinch valve, diaphragm valve, and so on, pressure safety valve, and so on. So each of the valve is designed or has been designed according to different flow characteristic and also the inherent performance. And number fourth is we have to understand what is the application of this valve. For example, FCV, flow control valve, level control valve, temperature control valve, pressure control valve, or pressure relief valve, so on. So we have to understand about the application, and then only we can select a proper valve sizing or proper valve selection to match or to meet your expectation of the application. Other than this, okay, after when we selected the valve, you can see all this diagram. You can see this is actually using a flange type. So over here, we can actually have a different type of valve end connections as well. So on the leftmost, this is a screw type or a threaded type. And on second left, this is a flange type. Then we have a butt valve, is a welding. Socket valve, butt valve and socket valve, what is the difference? So butt valve is actually parallel. Socket valve actually another end is to be inserted into this socket area. So for the butterfly valve, we have two types as well. So this is actually a lug type on the second right. So you can see there's a years or terlinger in this. This is a lug type. On this is a wafer. So this will be a lighter because there's a in a construction wise, this is actually lighter. So on the selection, it actually depends on the application and your requirement as well. Okay, so basically these are all the very fundamental or basic WAF information I would like to share to you all by today. So it's 2 o'clock right now. So basically, if we are talk about WAF, what are the basic information when you want to inquire or WAF, or you're looking for a WAF or you're asking for a WAF? At the very first and foremost, WAF type. So on the WAF type, next topic, especially next topic, my colleague we will share about the common WAF types to you and what are the difference of the types, the construction and the design. Secondly is a WAF size. So we need to know what is the WAF size you preferred or you have selected or you have done the sizing, you selected the size according which will match your expectation of your process flow or process condition. And the number third is on the WAF material. So on material wise, it's involved on a lot of part because for us on the process WAF itself, most of the WAF you're using the what you call is a steel WAF lah. Of course, we also do have a ceramic or PVC type. So it depends on the compatibility, we so called the chemical compatibility to the process medium, to the medium you're using, to the liquid or gas, or there's a what do you call or some acid, so on. So how do we select on the WAF material, on the body, on the bonnet, on the gasket, on the seat, on the seals, on the trim? So these are all differently. We can select differently according to your process requirement. On the flange pressure rating, so we have an ANSI flange, DIN flange, and GIS flange. And the WAF end connection, which I have shared to you all just now, butt valve, socket valve, raised face, flat face, and RTJ flange. So these are all different types. Okay, so basically these are the very fundamental sharing. Thank you. Is there any other comment coming in? Yeah, sorry, today we exceeded a little bit because I started late. There was some technical error just now because I'm trying to do this live from home. Yeah, thank you. If there's no further question, stay tuned to our next upcoming topic on next Monday again. So on every Monday, we'll be sharing this technical presentation to you or technical knowledge sharing together with you. On next week, we'll be having the topic. Today we talk about the fundamentals and the working principle, how actually a WAF works through the splinter, through the seat, through the washer, or in how is a trim design. So on next, we will get into more detail, which is on the second stage. We will introduce you about the common WAF types and also their design performance. Okay, thank you. If you do have any comment or questions,